Welcome to this final and seventh section of SAS programming course. In this one, we talk about data exploration using graphs and descriptive statistics. Uh, First of all, the main purpose of actions in this section is to gain an understanding of the data set in question. So basically, we do not make generalizing conclusions outside the data. So we do not perform statistical inference in here, but rather we just describe the data to the person in question using descriptive statistics and different graphics. And maybe just to clear, then this statistical inference side is not so much covered in this course, but it's rather the statistical methods, things like mixed models, linear models, generalized linear mixed models, and so on that are doing that statistical inference. So making conclusions out of a sample to a more general population, and that's a topic of continuation courses after this one. But first of all, before we jump into descriptive statistics, we talk about variable types and measurement scales. First of all, one important division is that statistical variables can be divided into categorical variables and numeric variables. And that's often quite important in terms of the methods and SAS procedures we choose to examine the variables. And they can be further divided into different types. There's different measurement scales for categorical variables. There's, first of all, nominal scale, which means that there is no rule available to put the values in order. And on the other hand, there's ordinal scale, which means that a rule exists to put the values in order. So, for example, a Likert scale, which means that the person agrees strongly, agrees somewhat, disagrees somewhat, or disagrees strongly, that clearly has an order for the values. Then, also for the numeric variables, there's different measurement scales. There's, first of all, the interval scale, where the ratio of two values has no meaningful interpretation and zero is not absolute. So, for example, temperature in degrees can use different methods, Celsius and Fahrenheit, and if you have, let's say, 20 Celsius and you have 10 Celsius, you cannot say that 20 is two times warmer than 10. So the ratio has no meaningful interpretation. Ratio scale, on the other hand, has a meaningful interpretation, and zero is absolute, meaning that if it's zero, it doesn't exist. And length, for example, whether we examine it in centimeters or inches, 2 meters is twice as long as 1 meter, and zero meters is meaning that there is no length. Then there is absolute scale, meaning it's mostly like ratio scale, but measurements can only occur using a one specific unit of measurement. On the other hand, numeric variables can also be divided into continuous and discrete, and maybe in practice this is the more important in terms of the method selection. Often you need different methods for continuous and discrete variables. Continuous meaning that in theory any value within a certain range can be obtained. So if we think about length, for example, we ca- it can be anything. For example, something that's between 1 and 2 meters, and it can be anything. But of course, the measurement accuracy makes it so that we sort of round it to millimeter or something like that. And often with variables that are continuous, we might use methods that are based on normal distribution. Then discrete, that means that possible values can theoretically be listed. So for example, counts, and in that case, Poisson distribution might be one possible distribution that would fit this type of variables. But also, it might be that there are only a few possible or realized different values in your data, even for a numeric variable, and that would make it so that it's basically then treated like a categorical variable in the end if you only run into a few possible values in your data. And also one practical thing is choice of method might be influenced, for example, by whether negative values are possible to exist. Yeah, but those are some things to consider about the variables you have, and then we go into the main topics of this section. First of all, we examine the distribution of a numeric variable. We compare the distribution of numeric variables across different categories of categorical variable. Then we examine the relationship between two numeric variables, and we examine the distribution of a single categorical variable, and we examine the relationship between two or more categorical variables. And each of these cases, they might have a little different SAS procedures associated with the with the situation, and we will see in this section quite many examples on how to do this with different SAS tools. The example dataset that we will mostly use in this section is this one. It's called experiment, and it has several numeric and several categorical variables. And here is a small sample on what the dataset looks like. Altogether, it has 175 rows, and for each row, we have information on nutrient, which is continuous variable. We have nitrate, which is also continuous, and we have yield, which is also continuous. And then we have three categorical variables. There's location, that has two different locations available, fertilizer with three levels, and quality with four different quality options. Also, again, a little technical reminder about the differences between the data step and the procs. This is mostly because in the earlier sections we have maybe been a little bit more focused on data step. Maybe in the graphic section we talked about procs mostly. But reminder that in data step, when you have some SAS dataset as input, you take it in using the set statement. And in this first statement, the data statement, that's where you give the name of the output data you are generating as the end result. Then you have additional statement, and it ends with the run, and semicolon. On the other hand, in the proc step, you start with the proc, and in the data option on the first line, you actually give the name of the input data. And that's, I think, sometimes causing confusion, because in the data step, that's the name of the output data on the first statement, and here it's mostly the input data you give in the first statement. Also, some procs, as we have seen, they might have out equals option, where you can also specify name of the output data on the first statement, but that's more rare. Then we have additional statements and also end with the run and semicolon. Okay, but let's go to business. So examining the distribution of a numerical variable. First of all, what is distribution? I have a definition that I pulled from Statistics Finland website some years ago already, I think, that says that the variation in the research subjects in relation to the characteristics being measured produces different values in the measurements. When these values are placed in order of magnitude and classified, they form the distribution of the variable. And in this definition, classification can mean, for example, measuring the length in full centimeters. And when we are examining this kind of a distribution, it's not enough to simply examine the location of the distribution, for example, the mean. But often it's much more essential, or at least as essential in terms of statistical methods, to examine also the variation. So the distributions can be examined for location, variation, shape, outliers, number of observations. So there's quite many aspects of the distribution that we can actually examine and get some interesting findings out of those. One way to examine distribution of numerical variable is to use descriptive statistics. So first, let's examine the yield variable using the descriptive statistics available in proc means. We just use the default ones to start. So proc means, we define that the data can be found from library reference KIR, and the name of the data set is experiment. And then in the proc means, we have a var statement where we can define the variable we are interested in. So that would be yield, and then we can just end with the run and semicolon. And running this code would give us this kind of output table. So this is the default set of descriptive statistics that this proc means gives us. So we have the information that we have 172 values for this yield. Mean is 133. Standard deviation is about 50. Minimum value 3.8 and maximum 261.2. Already we see that we might want to have maybe also some other descriptive statistics, and also we see that maybe there's quite many decimal places in these numbers, especially for the minimum and maximum. They give no additional information after the maybe first or second decimal.